Hi everyone, thank you very much. It's LoCO, by the way. It's a little bit awkward, but no. Okay, so we are LoCO, or LoCO2. We wanted to build something that's a data-driven design, specifically for low-carbon design, but without the actual data crunching. And the main reason is that today, when you look at environmental assessments, and specifically carbon assessments, what happens is that you have the LCA calculation, so the life cycle assessment calculation, way too late in the process. So once everything has more or less been decided, and you're basically doing it either for compliance purposes or to deliver a report to your client or something like that. So obviously, not obviously, but what we want to do is we want to have the designers consciously design based on the impact and hopefully make better decisions. And the kind of obvious answer to that is give them the data, and maybe that would work if we had AI agents doing all of this, but in reality, architects don't necessarily want to crunch the numbers and understand everything that goes into the building. So what we wanted to do is enhance BIM modeling with assembly level carbon data. So essentially provide designers within their design workflow already pre-calculated carbon assemblies or buildups, if you're using Revit, which have all of the data there. There's two use cases. So one of the use cases is, as a designer, I want to sort of iterate my design. So I want to pick one wall versus another wall and quickly see the impact of my design, and then make decisions based on that. And then the second thing is stakeholder engagement. So for example, I might be sitting at a client meeting, and as an architect, I get a question of, what did you do for the sustainability impact of your architectural components of the building? And I want to be able to actually answer that and influence the decision-making process. Something that, by the way, is a lot easier to do as a structural engineer because you have carbon and steel and timber, but as an architectural or as an architect is a lot harder. So what we actually built with LoCO is a plugin for Revit, and I'll explain a little bit what the innovation is behind this, because I'm sure you've seen other plugins. So essentially, what we're leveraging is 2050 Materials digital library, which is a UI basically to look at sustainability data of construction projects. And through that, we allow architects to customize specific assemblies that are actually relevant for the design. So they make 3 buildups of walls that they can actually use, and they're confident that their designer in Revit would be correct to use them. And then we leverage the API by 2050 to basically bring together these buildups into Revit in a way that they contain all of the relevant information to do the 2 use cases I mentioned. What we sort of end up with, and these are the Figma designs, it doesn't quite look like this yet, but it's essentially 2 things, and it's very important that it's 2 things, so we try to minimize as much as possible the exiting of the workflow of the designer. One is you select the buildups and you bring them into your Revit environment, and then the other is essentially a small dashboard which you can see the impact of your design, and you can export a PNG to put in your presentation for the client, for example. I'll pass over to Matteo for the demo.
So this is the demo. So we basically, the intended route is bringing materials, pulling the data from 2050 library, and package the data and into wall build-ups for all the Revit categories, so wall, floor, ceilings, anything that is needed basically for your design. And as you can see here, there's a initial interface that gives you that sense of what we are trying to achieve, which is basically what, as designer, we do. It takes experience, it takes time and trial and error, and basically what we are trying to achieve here is to remove that, lower the learning curve. So anyone can quickly access to real data, not dull build-ups like we usually architects do, have data in the model and be able to assess, to visualize the carbon associated to that specific solution. So in our mind, this should be a way to allow the designer to iterate more. Reality is usually with all the best effort we can put in our design, we tend to iterate very little number of solutions. Hence, obviously, there's always the chance to miss the best or the optimal solution. With this the innovation here is having a robust material library, very comprehensive, which is at the minute a gap in the industry, and on the other hand, a process that is not suited for more later stage, but kicks in at a very early stage. So you can make assessment, assessment in the sense, make judgment, so benchmark a solution against another one. So this is the impact we're expecting. So instead of having software, and this is, I'm an architect, I'm head of digital of my company, this is what I find one of the biggest failure in software, and that's the reason why I'm here trying to contribute. Software are most of the time are not user-centric, are scripting, coding-centric. And sometimes we forget that in the end there's a user and there's a use case. So we try to, in this case, to preserve the workflow. So the workflow was at the center stage. What we've done has an expandable library, so it's not a closed solution. It's open. It's open. We will share the access to the GitHub, but it's also in the philosophy of open in terms of we can grow the library. And obviously, this is more, let's say, from the human side. As I said earlier, you get with the experience to know that no 250 mil build-up cannot be an external wall. But what if we provide already a series of build-ups to, let's say, for instance, a young designer to visually understand that, yes, we probably are in the range of 450 millimeters of build-up for an external envelope. So it's time saving, which means money, but also more iteration, better designs. It's also mentorship, that's this added value of visually giving evidence of what is the embodied carbon of your solution, and sometimes leads to choice of new materials, new options, new alternatives, and then obviously conscious design. So future direction, we probably, there's many roads we can take moving forward. So a community assembly library, we can integrate with other software. There are recommendations for AI, machine learning. It's open to this sort of development. And of course, new materials or other fields, other parameters. This is the team. So it's been a pleasure to work with all those talented individuals from different backgrounds. That's something I would love to stress. Students, UX designer, programmers, data scientists, very few architects, good thing. So, I mean, probably this is one of the key of the success. So it has been a LoCO experience, and here is the QR code to access the GitHub.